All right, so the last time we got together, I went through some of these basic unit conversion type questions. Now, there are a few extra practice questions that I wanted to discuss. For boys, I haven't seen this as part of your test, these questions that are down here, but I will show you an example here in just a moment of what you might see. And it's important that you know a couple things that we don't have listed yet, but we're going to list them real quick. And so before I do that, let me just pull up something here. Okay. All right. So you will see questions like this where you're supposed to calculate the amount of fluid intake. And sometimes it will tell you milliliters. And sometimes it won't. So don't count on that being in here. You just need to know that milliliters is what you're looking for. And then there's some things here that are a little bit different. Like, so we know what ounces are, right? Because we talked about that last time. We know that 1 ounce is equal to 30 milliliters. So we know that. That's the equivalent that we know. We talked about that last time. But there's some other things that we may not know. We may not know what a pint is or what a cup is, and then how to make that conversion. So when we do that, there are some standards. And if you know off the top of your head, you can go ahead and just pop them into the chat or just tell me what equivalent are you supposed to know for 1 cup? If you don't know off the top of your head, I'm going to have to pull that up just to make sure I'm being consistent. So
240 milliliters.
Okay, thank you. And do you have like a do you have something that that you follow? Like, is there a printout or something of all these for you?
Yeah, we do have a printout, but I work in the hospital.
Okay, thank you.
So,
So but it's the same information, right? It's consistent.
yes.
And then what is a pint? So by process of elimination, just in case, which you should be seeing this, but a pint is the same thing as 2 cups, which is the same thing as 480 milliliters. Okay. So we can just kind of break that down and make sure we know our equivalents. So the other thing is helpful is like, we know that a glass is 8 ounces. So then we can kind of make we can break this down. And we know that this is 4 ounces of liquid. We know that this is 8 ounces. Tuna fish, we can say that's no ounces, right? So that's not liquid. Is a popsicle considered a liquid? What do you think? Yeah.
Yes.
If instinctively you said yes, that would be the correct instinct because it's just frozen liquid, right? So it still counts. And then what is a half pint? Well, half pint is 1 cup of milk. Okay. So this kind of helps us to break down what some of these are so we can make some calculations. So 4 ounces, and we really don't need to do too much calculator work here, if you can do this in your head, or if you want to pull out your calculator. So 4 times 30 is 120 milliliters. 8 ounces, which is the same thing as a cup, is 240 milliliters. Tuna fish sandwich is 0 milliliters. Not that you need to indicate that. 3 ounces would be 90 milliliters. And then 1 cup, which is the same thing as 8 ounces, is going to be also 240 milliliters. And then all you're going to do is add those up. So 120 plus 240 plus 240 plus 90. And then that, I will use my trusty calculator in. So 240 times 2 plus 120 plus 90. And you should get 690 milliliters as your total amount. So the total intake that was 690 milliliters. And I was just going to underline that. So you'll see questions like that. I think there are 2 questions set aside on your, when you take your exam, it'll be very similar to this. They'll obviously use different things. Where it gets a little bit tricky is like where they talk about ice and then water and popsicles and then Jello and things like that. Some of that nuance, you just need to make sure you know which times to count it as liquid and which times to ignore it. So if it's a tuna, if it's any kind of sandwich, you know that we're not worried about liquid. We're worried about things that are obviously liquids. So Jello is one of those ones that's a little bit kind of, you know, basically it is liquid, but it's been, you know, congealed using, you know, enzymes. And so you want to know, like, well, what is it? I would say count Jello as a liquid, but count pudding as a solid, if that makes sense. But if you've been taught otherwise, follow what you've been taught when you're calculating these. But they're going to be like this. It's going to be like a popsicle. It's going to be like milk. They're going to give you the things. And the thing that they're really just trying to make sure they're testing you on is that you can convert cups to milliliters, pints to milliliters. And if you can do that, then you should be good to go. All right, we'll come back to that. Let's go back to practice set here. Now, I told you I'd give you some pictures of syringes. I didn't get that ready yet, but I wanted to show you what different syringes might look like, just to pay attention to. So this right here is showing you, and I'm going to use a spotlight here. Nope, maybe not. There we go. So you should see my red dot here. And this red dot is just indicating you have this thing, it's called a tubex. And what a tubex is kind of, it's just a modified way of looking at injectables. And what you want to pay attention to is how these increments are listed. So you can see that they're listed 2 milliliters, 1.5 milliliters, 1 milliliter, and half milliliter. So what that should tell you is that these are decimal milliliters, meaning if this is half, which is 0.5, then we have to see, okay, is it going to be in increments of 1s or 2s or 10ths, basically, or by 2/10. So the easy way to kind of craft this, and I apologize if this is something you're like, yeah, I know how to do this. Why are we working on this? I don't know where you're at. And these are things that are commonly missed on the on these exams. It's not so much the math sometimes, it's just, can you read a syringe? And it's what's in my notes. And so I just wanted to kind of cover it. So I'm going to look here. I'm going to say, okay, I know this is 0.5 and I know this is 1.0. Let's just count 0.5, 0.6, 0.7, 0.8, 0.9, 1.0. Okay, so now we know that these are in increments of tenths, which tells me that if you get an answer, first of all, that answer should be on the tubex, okay? And it looks like it goes up to, so this is 2.1, 2.2, 2.3, 2.4, 2.5. So it goes anywhere from 0.1 all the way up to 2.5 as far as your increments. And so it's, once you know that, then you know what to do. Now, sometimes you're not going to be given the label, but most of the time you should see a label. If this is your first time looking at a label, a couple things. The bold print word is the name of the medication. Then you have the strength of the medication that's listed off to the side. And this is what's important for solving these types of questions, is knowing what the strength is. So for this, it's 50 milligrams per milliliter. So every milliliter of this injectable will give 50 milligrams of the meperidine. And you could see that it tells you it's for intramuscular or subcutaneous use. And then it can be used for IV use, but for this, you know, most likely we're talking about intramuscular or subcutaneous. When you're looking at the questions, you will see that it says the order is 75 milligrams intramuscular, okay? And then you're just basically marking the syringe. Now, I don't think you guys have too much syringe marking to do on your test, but if you do, we'll practice that as we kind of move along. So let me just see here. Okay, yeah, so somebody was asking about, yeah, so I'm posting all of these will be recorded. I'm giving the Zoom link to your lab instructor or your instructor. I'm also posting these on my YouTube page, so you can access them whenever and from whatever device. So yeah, if you need to leave or if you can't tend them all, or you can only tend some, they'll always be available to you on Blackboard, or not Blackboard, on YouTube. Maybe on your Blackboard if your instructor puts them there. All right, so let's take a step back and let's start by talking a little bit about medication calculations. These are usually pretty straightforward. And what I mean by that is, I apologize. Before I do that, I wanted to show you some more syringes. Okay, this is the last thing I wanted to show you, these example syringes here. So with these example syringes here, you can just see that we have different things. Like this is measuring cc's. Notice that there's a 0.90 cc. That means each of these little ticks is actually into the hundredths place. So if you were using this syringe and we were looking at the cc's, you could calculate 0.75 cc's, which is the same thing as milliliters. Okay. This 2, 4, 6, 8, 10, 12, 14, 16, and that looked like an M. I'm not entirely sure what they're referencing here, but these cc's. So this is a 1 milliliter syringe. That 1 milliliter syringe can be down into the hundredths place when making a calculation. And that would be something you would use if you were administering something that was 0.85 milliliters or cc's. This is the type of syringe you would use. And then hopefully on your test, you wouldn't have this very microscopic looking image, but if we blow it up, you can see the little tick marks. And so here's 0.6, 0.61, 0.62, 0.63, 0.64, 0.65, 0.66, 0.67, 0.68, 0.69, 0.7. And that's how you would differentiate and read that type of syringe. Now, when you get down here, this is another where it says units 1 cc, but this is a unit syringe. So this is 10 units, 20 units, 30 units. The reason I bring this one up as well is because these increments are not by ones or tenths. They're actually by twos. So it gets 10, 12, 14, 16, 18, then 20. So these are in two unit increments on this type of syringe. So again, I just put in my notes, I just want to show you the difference between what these different syringes might look like in the event that you have to pick between some, or if you're marking them, just make sure you're marking them appropriately and that you're clearly marking the increments that are listed either on the syringe or on the tubex or things like that. All right, so let's go back up to the top. So for the most part, when you look at what are considered your drug labels, they're going to look a lot like this. It's going to tell you the total amount of capsules you're going to see the strength of each capsule, and then it'll tell you the name. Sometimes it'll tell you the generic name, or it might even be the generic version of the medication. And one of the things that you want to pay attention to is just making sure you're familiarizing yourself with this. And one of the things that I found helpful for myself and what other students have found helpful is go through and just look up different pictures of drug labels and get an idea of what these things look like, because some of them look different. Some of them look like this. You can see Dilan, it says 125, and then there's a strength. V-Silin K tells you 125 and some other information here. And we're going to go through this stuff, so don't get all worked up just yet. Mycostatin, and you can see what some of the strength and concentrations are associated with that. Lanoxin is tablets. You'll notice that tablets usually just tell you milligrams. Or do you remember when I mentioned last week, or if you watched it on the recording, I mentioned sometimes you'll see it listed as micrograms, so it looks like a little UG. That's what that is. So this is actually telling you that this medication is available in as 250 micrograms per tablet, but that 0.25 milligrams is the same thing as 250 micrograms. So the same thing. So you don't multiply these numbers together. The reason that there's two numbers here is because it depends on what the order says. If the order says the order's in micrograms, now you can use micrograms. If the order's in milligrams, now you can use milligrams. If you don't have that available to you, then you just have to do a conversion, and we'll show some examples of that. See what else we got. Here's another medication, Tagamet tablets, 400 milligrams. So it just tells you on the label, but notice that each label looks a little bit different. Okay. And some of that is because obviously there's different pharmaceutical companies. So SmithKline, Pfizer, they're going to look different depending on how they made it. Now, when you have like an oral or liquid type of medication, you're usually going to be looking for where it says milliliters. So milliliters will stand out to you when you look at those drug labels, and they will say this is a liquid type of medication. So 250 milligrams per 5 ml for Aldamet. Sometimes it just tells you milligrams per milliliter. There's no 5 or anything like that. And then sometimes it's big, like it might say 400 milligrams per 250 ml. So everything is just a little bit different. Here's that tubex again. This is Mepridine. 50 milligrams per milliliter is the concentration, is the strength. I just want to see, there's that again. Here's heparin. Heparin's available in this particular tubex as 10,000 units per milliliter. And then finally, morphine. You see the whole vial is 20 milliliters. Tells you it's a poison. Morphine sulfate is 15 milligrams per milliliter. So you know what to use when you're doing your calculations. So let's go back up to the top. Let's minimize this since this probably looks crazy out of context here. And let's look at the first question and let's practice setting that up. So last time I mentioned dimensional analysis, and dimensional analysis is usually like my preferred method of explaining these types of things. However, you can use any method you like in order to answer these particular questions. It just depends on what you prefer. So if you prefer like order over have, that's how you've learned it, then these work out perfectly. If you prefer just looking at this and giving an answer and saying 2, then you're instinctively right, but remember, they do want you to write and show your work. So let me just show you what sorts of things you can show your work with. So I'm going to try and annotate with this here, and then if it doesn't work out, I might just draw it out. So I'm going to start off, actually, I am just going to draw it out because already I can tell I'm not going to like this. So let me turn on my camera. Oh, the wrong camera is, you're seeing it's going through a filtered piece of paper on my laptop, which doesn't help you. So there we go. That's what we want to see. So there's a couple of ways to do this. I'm going to show you the dimensional analysis way first, and then I will show you the ordered over half version second. So let me just get this square here because it's bothering me. It's not square. All right. So if I'm doing this order or just dimensional analysis, I'm going to start off with my order, which was the 500 milligrams. So my order is 500 milligrams. Then I'm going to look for my conversion. That's where I'm going to look at the label. Remember, the label said we had cephalexin 250 milligrams per capsule. So, and then what I'm looking for is how many capsules. So 250 milligrams per capsule. Then I'm just going to 500 divided by 250, and my answer is 2 capsules. Caps is usually fine. Something you should know, you cannot give a half capsule because capsules have this little, the medication is usually a mixture and there's multiple things that are kind of in little beads, and you wouldn't be able to give exactly half of the medication. So you can't give somebody a half capsule. Tablet you can give half because we can assume that a tablet is scored down the middle. So you could give a tablet. This is a scored tablet, but you can assume that you can give somebody a half of a tablet. You've probably even seen that where somebody has received half of a tablet for something. So that says scored, not scared. If I'm doing ordered over half, what's my order? My order is the 500 milligrams. What do I have available? The 250 milligrams times my quantity, which is the 1 capsule. So you have options. If you prefer it and this looks more pleasing to you to do, then just do that. You're doing it's, there's no one correct way. They're both going to give you to the same answer. Okay. Now, something else that sometimes pops up with these, and I'm going to show you this right here. Sometimes it tells you some extra things. Now, you may still be learning some of your common abbreviations. I'm not sure where you are with that. So PO, you should know, means per oral or by mouth. BID means every 12 hours or twice a day. Okay. So how do you know when it says how many capsules to give? How do you know if they're talking about how many to give per day or per dose? And I would just tell you that for the most part, when we're talking about making a calculation for this, we're talking about the per dose, unless it specifically asks you how many to set aside for the day or something like that. But for the most part, you're going to say per dose. And so that's why you would just worry about the order divided by 250. Usually most students are not struggling with these. They seem a little bit more intuitive. A lot of times the problems come in is this basic stuff. I call it basic, but it's like the simple stuff that you think that there's more to do, but it's literally just doing a conversion. And unfortunately, it's the ones that tend to trip you up the most. So just take a break, breathe a little bit, remind yourself that, oh yeah, I gotta, what is this question asking me? Let me make sure I'm answering it appropriately. Let's look at something like this, number 15. So it says you're to administer 250 milligrams of dilantin, PO, by mouth. How many teaspoons will you give if it's labeled as shown below? So if you're given teaspoons, hopefully you know that it's a liquid, not a tablet or a capsule. So that helps, that at least answers one part of the equation. And so since we know that it's a liquid, we can assume that and with some certainty that it's a suspension type of question. Now, suspension typically means that it's already in a liquid state when you receive it. The difference between a suspension and a reconstitution is water is added at the pharmacy, whereas the liquid is it gets shipped liquid. So if you've ever, if you've ever had when you were a kid or you've had kids where they obviously have a hard time swallowing those big giant antibiotics, they might prescribe them the pink liquid amoxicillin or the white liquid cephalexin. You usually see it and it's kind of like it's got like a chalky kind of taste to it, somewhat flavored, but they added water at the pharmacy, shook it up, and then gave it to the parent and said, give your kid, a teaspoon of this every, twice a day or whatever, or every 12 hours or whatever they told them to do. And whereas this is more like your cough syrup, it's already a liquid. Water did not need to be added. The liquid component was already there. So that's the difference between a suspension and a reconstitution. And we'll talk about reconstitutions on Thursday. All right. So the next thing is with something like this is we can still do the same process for answering this question. We can follow and utilize dimensional analysis, or we can follow and utilize ordered over half. So let me go back to my camera. So the order is 250 milligrams. No, it isn't. Yes, it is. That's my order. And what do I have available? I have 125 milligrams per 5 ml. So what I'm going to do is I'm going to set this up because I always start off doing kind of like a dimensional analysis methodology just to kind of show you both ways. And that way, you can ignore one way and focus on the other way. So this is one way that you could set this up. And what this would do is give you the answer in milliliters. And then we would just convert milliliters to teaspoons. And then I'll show you an alternative way in just a moment. But this is how we would start this up. That's my order. And then I'm making the conversion, the 125 milligrams per 5 ml. And I'm just using the information that was given to me on the label. When I do that, I get an answer of 10 milliliters. So 250 times 5 divided by 125 gives you 10. Or for simplicity's sake, and what I usually do is I take 250 divided by 125, which is 2 times 5 is 10. So you don't even need your calculator for this one. But if you don't feel comfortable doing that type of math in your head, then just use a calculator. You get to use one on the test anyways. Then if I've done it this way, I have to do one more setup. I have to convert milliliters to teaspoons. And you may recall that 1 teaspoon is equivalent to 5 milliliters. So 10 divided by 5 will give me an answer of 2 teaspoons. Then the alternative way, I can take my order over my available times my quantity. So my order is the 250 milligrams by mouth, and then I have available 125 milligrams, and then my quantity is 5 milliliters. I get 10 milliliters, and then I do that same conversion, which is the same thing as 2 teaspoons. So I skip this step here because it's written up here. Lastly, what I'll mention is you can save another step here. If you know that 1 teaspoon is 5 milliliters, then you could just substitute 1 teaspoon for the 5 in either case, and then you'd still get the same answer, the 2 teaspoons. So you can substitute that should you desire to do so. You would do number 16 pretty much the same way. It tells you you have V-Silin K suspension, 150 milligrams by mouth, QID. So QID means 4 times a day. So you're going to administer 150 milligrams 4 times a day. Now, sometimes, especially for your class, it might just say, how much would you administer? And it doesn't tell you milliliters or anything like that. When it's a suspension, subcutaneous, intramuscular, you know you're dealing with a liquid. And so when you know you're dealing with a liquid, then you know that your answer is going to be in milliliters. Okay. I got that question asked to me a lot last semester for the Boyce 110. It's like, well, how do we know what we're looking for? And then once I mentioned that if it's sub-Q, intramuscular, or if it tells you it's by mouth and it's a suspension by mouth, it's going to be in milliliters. If it's, if it tells you by mouth, it could be a capsule or tablet, but then your label will also tell you what you're dealing with. So this label tells you it's a suspension. The order tells you it's a suspension. And then the suspension even tells you that it's 125 milligrams per 5 ml. This also is indicated as 200,000 units per 5 ml. So if the order for this was, 400,000 units, you would still set this up the same way. Okay. So 125 milligrams per 5 ml, and the order is 150. So let's go back and we can do this one here. And I'm just going to do this ordered over half. So my order is 125 milligrams. But what I have available is actually 150 milligrams for every 5 ml. Now you might be looking at that and saying, oh no, it's going to be a number. The order is less than what's available. That's okay. That just means we're going to give less of a milliliter when we do that. So I would take my calculator, 125 times 5, which gives me 625, divided by 150, and I'm going to get 4.16 repeating. And that just 6 just keeps repeating. So what am I going to do? What's going to be my answer for this? My answer is I'm going to need to round to the nearest 10th. And so my answer would be a 4.2 milliliters. Did I do that backwards? I actually set this up and I used the information in reverse here. But if that was the, so I switched the order and the what you had available. But if you had a medication where the order was 125 and what was available was 150, and you got an answer that looked like this, like in your calculator, it says 4.1666667. You can see on mine, you can see how it's repeating. Okay. You would just round that to the nearest 10th, 4.2. So for simplicity's sake and for sanity's sake, let's write that the correct way. The order was 150. The available was 125. Oops. Sorry. That's supposed to be 5 milliliters. So 150 times 5 divided by 125 gives me 6 milliliters. So those of you who did that and you got an answer 6 milliliters and wondering where I got 4.2 milliliters, it's because I flipped these. So make sure if you are answering these questions and you get some wrong or incorrect, that you make sure that you double check that you didn't flip your words around, because that can happen. So All right. So I'm just gonna go ahead and open up to any questions because that's what I wanted to talk about today, just to kind of keep it simple. We went through like the initial review last time that I kind of went through what to expect on the test, and over the next couple weeks, I'm gonna break down, just take our time, and just kind of go through and practice some of these. If you're not if you haven't started to do so already, start practicing these questions on your own. I will have some additional questions to kind of go through. And then my intention is to put together like a practice test for you that you can practice taking. You can time yourself, and then you'll have a key, and that way you can kind of take a look and see how you did with that. But in the meantime, there's some practice questions that are posted on the OneDrive folder for you to have access to. And so I'll just tell you to just keep working through those. But if you have any questions, go ahead and ask away.
I think the biggest issue I'm having is just knowing when to round, like to the tenths or to the hundreds, or like, for example, I'll get like 0.75, and in my mind, I'm like, 0.75 sounds legit. I'll just put that in, and they wanted 0.8.
Mm-hmm.
So like that's where I'm struggling with practice.
Okay, so let's talk about that for a second. Where are you practicing on ATI?
Yes.
Okay. So there's a couple of factors. So the main, and you probably saw this, or maybe you already know this, so don't, but the main rule for rounding, with this stuff, if you have a number that's greater than 1, such as, let's say I have 2.375 milligrams, you're going to round to the nearest tenth. So that would be 2.4 milligrams. If you have a number that's less than 1, as an example, 0.375 milligrams, you're going to round to the nearest hundredth place, which would be 0.38 in this example. Now, there's a caveat to this. The caveat, and by the way, remember, we don't round basic unit conversions, meaning like if I'm going from milligrams to grams or micrograms to milligrams, milliliters to liters, you do not round those. You would round going from pounds to kilograms, but do not round basic unit conversions. This is if you're doing like we did here, where I have an answer and the order over half was 125 over 150 times 5 gave me 4.166666666. You would round that to 4.2 milliliters. That's what rounding is referring to when you're doing these things, or what we're talking about here. Now, in reality, you might have a syringe that only measures to the 10th. So if that's the case, then your answer here would be 0.4. But according to the rounding rules as dictated by the campus, and then what you'd likely, or the college or CCAC, and what you're likely to see on the actual test, which is a little bit different than what you're seeing on the ATI, you're going to follow these rounding rules as they're listed here. The ATI, and one of the things you can do is if you run into an issue where you're getting something wrong on the ATI, email me a screenshot so I can address it and make sure I'm seeing why you're getting that answer like marked wrong. Because sometimes it is a rounding error. Sometimes it's we're disagreeing on where the rounding should occur. But if instinctively you are rounding to the nearest hundredth for a 0 point something number, you're doing that correct. And if you're rounding to the nearest tenth for a number greater than 1, you're doing that correct.
Okay, so you more than likely that was the 0.75 ATI, just rounded it to 0.8, but I'm going to want to do it like that on the test, 0.75.
Correct. Yes. Yeah, that was my long way of saying exactly what you just said.
Okay, perfect.
Are there any other questions? All right. Well, I will be here again for you guys on Thursday, same time, 2:30, 3:30. If there's a time, or if you know of other students who can't attend and another time would work better, or another day time, just email me and let me know, or let your instructor know and she can reach out to me. Because I will, I know I'm going to try and add a Friday review session, and I might hybridize it between Boyce and Allegheny. And so I just want to make sure, or let you know that you do have some options. So if you decide that you want to come in during that time, or if you need an alternative time, or someone else needs an alternative time, just let me know and we'll make it work. But other than that, I think that's, we'll go ahead and stop there for today. And as I mentioned earlier, I will post this on YouTube for your reference. And if you have any questions during the week, please feel free to email me.
Thank you.
You're welcome.
Thank you.
You're welcome.
Thank you.
You're welcome.